Alright, as I asked all of you to do, I'm going to go through here and demonstrate how adding non-concurrent forces graphically can work by doing this kind of chain rule. So what I've got here sketched up is the basic can you solve this problem, which is you've got a coordinate 4, 5 here, 8, 0, 10, 0, and 0 minus 4 there. I'm going to sketch in the forces now without a header on them, so I'm going to go here, line from the end of that, and I'm going to use a scale of 1 to 10, so I'm going to go at 10 angle 45 to represent 100 kips. And I'm going to do the same now, a line from the end of here at 5 angle 110. And I'm going to do the same now from here, a line from the intersection of there, and that is an at 20 angle 253. And finally, line from end of here at 15 angle 305. Okay, so that's what that looks like to scale. So let's do this. Let's start. We're going to go around the pike this way. So we're going to do this. We're going to actually go ahead, and I know you all like to do, you can do a better job than me, but I'm going to slide this vector. I'm going to draw a line from the, to make it a little bit easier, I'm going to change my current layer now. Change it back to center on a line from end of here, and I'm going to turn off my F8, and I should be able to get kind of an implied direction here. I'm going to just hit right click, extension. If I turn on my object snap, object track, right click, extension. I'm not getting it. So here's what I'm going to do. I'm just going to go a line from the endpoint here to the endpoint there. Extend, screw that. Make sure I grab that right one. And now I'm going to move. If you remember, this one is going this way. I'm going to add my forces concurrently from the endpoint there. I'm going to move that one to the endpoint there. And this one here, I'm going to move this one from the endpoint there. Sorry, move. Cross, remove from the endpoint there to the endpoint there. And so we know that this, of course, is my point of application. So now I'm going to draft from the endpoint there to the endpoint there. Get rid of these two. And that, of course, I'm going to change back to the object layer. So we have added two vectors, tip to tail. And we're going to go ahead and add now these two vectors, tip to tail, which shouldn't be too bad because I can move this one from its endpoint here to the intersection. And I can move this one from the endpoint here to its endpoint, and we know that those zoom extents, we know that these are the two, line from the endpoint here to the endpoint there is our sum of those two vectors. I'll get rid of those two, make that an object layer. And so now we have essentially two vectors, one going this way and one going that way, and what we know is that line where they intersect here is going to be where we're going to add those up. So all kinds of different ways to do it, but line from the midpoint of that to the endpoint of that will work, and line from the midpoint of that to the endpoint of that will work. And we're putting these on a different layer so we can do finally fillet radius 0. Take this one, and that one, and now we have its point of concurrency right there. And we know that point from our calculation should be something like 2.53 away. Let's double check. Distance from the endpoint here to the intersection here, and there it's 3.71. I think that's actually what we calculated, but we're going to check that with the mathematics of Mathematica. Escape, zoom, extents. Right, this should be as correct as anything else. So this one, if you remember, this is going up. So we're going to go ahead and slide this one down. So this one was these two were going up. Move that to the endpoint there, to the intersection here. Got to be careful about it when you do it. Move it from the endpoint to the intersection. And those are going up, and then we're going to add this force, which was going back. These forces were going up, these forces were going down, if you remember. So we're going to go ahead and move, get rid of this, erase. We can also learn to grab, left click spacebar, grab that and go to the endpoint. And what we have then now is the sum, which I think was like 212 if I remember, line from the endpoint there to the endpoint there. We're going to change this to object, list it, 212, and if you remember now, this was a circle. Let's see, line from the center, line from the endpoint here, perpendicular to that one. And if we move that now to that point, we get its kind of to the endpoint there. That becomes the number we were looking for, 3.7. And if we remember, that's essentially, we know that this is the solution. And here's what we know about this force. This force has the same x and y and z components as the 3 or 4 subforces, and it has the same moment. The moment of a force is equal to its magnitude times its moment arm, which is that perpendicular list distance. And so we'll write these down and check the math, but eventually it's going to be easier to do these by math. But you want to go and do a couple of these until you can trust it. The magnitude of this was 212.55, and its direction was 292.45, and its moment arm, or where its moment arm was 3.70, and the point that it crossed the x-axis, if you wanted to slide it down to there, which was the question that was given. Remember, you can slide any vector along its line of force. I am going to go an ID from the intersection of that, knowing I started at 0, and it's 4.005. We'll double check that we started correctly. ID the end of that. All right, so that's a lot of quick drafting, but remember what we did here is we just added vectors tip to tail, slid them, always added them from their point of concurrency, and then we did 2 together, another 2 together, and we added those together, and we should come up with the exact same solution as if we do it by mathematics. Mathematics is generally vector mathematics, and I'm going to really point you in the way at this point, like I said before, learning to use Wolfram Alpha if you can't really control your calculator and or spreadsheet. But move on to a programming language. It's going to make things a lot easier as you get off into industry and you're realizing what's going on behind some of the programs you're using. So thanks for listening. That was the Can You Solve This Problem?